Hello everyone, my name is Rishi and this is my second video. So the topic of today's video is microservices. So in this video we will see that what is microservices. So before moving in this topic, that what is microservices, we have to learn, we have to know about that what is monolithic monolithic architecture. So in this video we will cover microservices architecture. Microservices architecture, but before moving in this topic we will have to know about some thing about monolithic architecture. So what is monolithic architecture? Um Basically, monolithic architecture is the traditional way of building application where the entire application is developed at one single unit. So what is monolithic? So monolithic is the traditional way of traditional way of building applications where the entire application is developed as one single unit. Okay, so my monolithic architecture is nothing but it is a traditional way of building application where the entire application is developed in a single unit. In this style, all the features like login, product catalog, order management, and payment are built together in one big code base and connected to the common database. At first, this approach is simply and easy to develop, test, and deploy. Some applications work well as monolithic because everything it is in one place. However, as the application grows, monolithic architecture shows many problems. The codebase becomes very large, making it difficult for developer to understand and maintain the code. So, a small change in one part can affect the whole application and may require redeploying the entire system. Scaling is also difficult because you cannot scale just one feature into the whole system. So the whole application must be scaled and vast, and different teams cannot and in monolithic architecture different teams cannot work independently as they are tied to the some code and database. Technology is choice Technology choices are limited because the whole application must use the same stack. Failure in one module can crash the entire application, reducing reliability. Testing also become harder as the system grows. So basically, monolithic architecture in this architecture, the application the whole application is bind into a single unit. So if we see the diagram of monolithic architecture, so we will understand it by architecture by a diagram. So we will understand it by a diagram. So let's see. Suppose this is the user interface. Okay, this is the user interface. This is the user interface. User interface, basically this is the front end part. This is the front end part. Okay, and it is connected to the our backend system. So it is connected to the backend system. It is connected to the backend system. In this backend system, there are many logics. We build many logics like we write service A. Okay, then we write our service B. Service B, and then we will write our service C. Service C. And for all these services, there is a common database. So for all this service, there is a common database. Okay. So for all this service, we have a common database. So I think this is clear to all, that in monolithic service we will create a single project in which we will write our all the services like service A, service B, service C, and for this all service we have a single database. Okay, this is the monolithic diagram. This is how a monolithic diagram looks like. Now we will see that what is microservice. Okay, microservice is nothing but it is a updated version of monolithic architecture. In nowadays, in many big companies, the developers use the microservices architecture instead of monolithic architecture. So if you say that what is microservice architecture, so microservice architecture is nothing but microservices solve this issue by breaking the application into small independent departments, and they can be developed and deployed and scaled separately. Okay, each service has its own database. Every service will have their own database and can use different technologies. That's why modern companies moved from monolithic to microservices for better scalability, maintainability, and agility. So, if you ask in short that what is microservice architecture, so microservice architecture is nothing but if we define it, then we will say microservices 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 solve the issue of monolithic architecture. Microservice architecture by breaking the application into small independent services. Okay, now we will see an diagram, then all the concept will be clear. So we will look a similar diagram of microservices architecture. So we will draw a microservices diagram, that how a microservice look like. In this we will create a user interface which is nothing but a front end part. So here, so it is the front end part, user interface. Okay, and this user interface is connected to our backend system. So this front end part is connected to our backend system, but we will create we will break down our project into small parts. Okay, this is microservice A, this will be the service B. Instead of writing all the code in one project, we will create different microservices to, to write different logics. Okay, so it will connected to it will connected in this way. This is service A, service A. This will be our service B, and this is service C. Okay, and the most important thing, that all the service have their own database. Okay, every service has have their own database. So let's assume that this is the database. for every service there will be a separate database. So database 2 and database 3. Okay, so this is the diagram of microservices architecture. So let's recap that what we had learned till now. So microservice solves the issue of monolithic architecture. So what is monolithic architecture? A monolithic is a traditional way of building application where the entire application is developed as a single unit. This is our user interface, the front end part. This is our whole backend system in which we write all our logic into a single project, service A, service B, and service C, and this is our database which is connected to this system. But in microservices architecture, it solves the issue of monolithic architecture by breaking the application into small independent services. So this is the diagram of our microservices architecture. This is the user interface. But in this, we will break our microservices. We will break our backend system in different parts. There will be a different logic for service A, there will be a different logic for service B, and there will be a different logic for service C. And there is the separate database for every services. So now we will see that in 2013 there is a man named Martin Flower. So it he gives the he breaks the concept of microservices into 9 parts. Okay, basically he and his friend whose name is uh, whose name is James Lewis. So in 2013, with the help of his friend, and he give us a concept that micro if a system if anybody used the microservice architecture, then they should have to follow these 9 concepts for building the application. So what are these concepts? So the first one is componentization. Componentization via services. The first point is component componentization via services. So what is this? So this is nothing but componentization via service means breaking a large application into small independent parts called services. Okay, componentization is via services means breaking a large application into small independent parts called services. So if you want to build a project using microservice architecture, so the first point you have to understand that if you want to build a project, then you have to break a large application into small independent part called services. Instead of writing one big problem where everything is tightly connected, developers divide the application into separate services, and each services handles a single task. Suppose microservices A will do their own job, microservices B their own job, and microservices C will cover their own job without connecting to without disturbing each other. These all system will work independently without communicating each other. This will run on their own port number. Okay. For example, if we took example, then I will see that in e-commerce application there could be a login service. Okay. In e-commerce application there will be a login service, a product catalog service, an order service, and a payment service. Each of these service works independently but can communicate with others when required. Okay, this whole service will work independently but communicate with each other when required. The advantage of this approach is that if one service fails, the other service can still continue to learn. Okay, so the main big advantage of this compound componentization is that if one service fail, then the other service will work properly. So this is the first advantage of the componentization. Okay, it also becomes easier to scale. It is also become easier to scale because if the product service is getting high traffic, we can scale only that part instead of the whole system. Another big advantage is maintainability. It is easy to maintain. We can maintain our service A, service B, service C independently. So these are not connected to each other. So it is very easy to maintain the service as a single part. A change in one service does not affect the other. If we change the code of service A, then it will not disturb the service B. Okay, so developer can use different programming languages and technologies for different services. Testing also become easier since each service can be tested separately. Overall componentization via service makes application more modular, flexible, and reliable. So these are the main advantages of componentization, that the our service will be modular, scalable, maintainable, independent, and we can code in any language. Suppose we are writing service A in Java, we can write our service B in we can write our service B in Python, and we can write our service in C or C plus C++. So it gives us a flexibility to write our code in any languages. Okay, but in monolithic architecture, we have to write all the code in same languages. Okay, so this is the first concept of microservice architecture. So what is the second concept that is given by the Martin Flower? So the second is organized. Second concept is organized around around business capabilities. So what this capabilities say that service are not designed randomly or based on technical requirements. Instead, they are organized around business capabilities. Businesses capability means a specific function that the business provide. So we will took example. So for example, in a bank, okay, listen carefully. In a bank, important businesses capabilities are account management. We do a fund transfer, loan processing, and customer support. These are the main branches which are used in bank. What are the businesses? First is account management, fund transfer, loan processing, and customer support. Similarly, in a e-commerce system, the business capabilities are managing customer, managing products, handling orders, and processing payments. So each of these capabilities is implemented as a separate service. Okay. The main idea is that the software system would directly reflect how the businesses work. This alignment ensure that whenever businesses needs changes, the software can also involve easily. For example, if the company wants to add a new capability like wallet payments, developer can simply create a new payment service. This principle reduces the gap between businesses, teams, and technical terms because both talk in the same languages of capabilities. Organizing around business capabilities makes the system customer focused, business friendly, and easier to extend. Okay, so in simple word, if you want to define that what is organized around business capability means each microservice, each microservices means if we define that micro each microservices is built to handle a specific business businesses function or domain. Okay, so this is the definition of the organized. What is organized around business capability? Each microservices is built to handle a specific business function or domain. So if we took a diagram, so let's explain, let's understand the organized around business capabilities with the help of a diagram. Okay, suppose this is our client. Suppose this is our client. Okay, this is our client. And suppose this is the payment gateway. Suppose this is the whole backend system. Okay, and this is our payment. Suppose this is the API gateway. This is nothing but this is the API gateway. Okay. Suppose a client wants to payment. Okay. So it will connect to our API gateway. And this API gateway further connects to the several business capabilities. So these are the different services for our businesses. Okay, and we will take a last service. So suppose Suppose this is the catalog service. Catalog service. In this service, we will only write those code which is related to this service. Okay, only catalog service. And in this service, in the second one, in this service, we will only write the shopping cart services or logic. Okay, in this service, we will write only the shopping cart logic or services. Yeah, service. In this service, we will write only those code which is used for discount logics. And the last we in this we will write our ordering logic. Okay, so this is the whole system how the organized around business capabilities means. So each microservice is built to handle a specific business function or domain. Catalog service will handle the catalog logics. Shopping cart will handle the shopping logic. Discount service will handle the discount logic, and the ordering service will handle the ordering logic. And for all these logic, there will be a separate database. There will be a separate database. Okay, so I will not make the whole diagram. So suppose this is our database where the all the details of the services are maintained. Okay, this is not this is our database for each services. Okay, so I think the point 2 is clear, all of you, to all, that each microservices is built to handle their specific business domain. Okay, so we will move on the next topic. So our next topic is our next concept that the Martin Flower has given, that if a service, if you want to make a microservices architecture, then this point are very important for making your application as a microservice architecture. So the third point is smart endpoints and dump pipes. So the third point is smart endpoints and dump pipes. Okay, so what this point says, so listen carefully. What is the meaning of this point? So smart point, yes, smart endpoints and dump pipes. So the basic concept of this point is that the logic of our code, okay, the logic will stays inside services. Okay, the whole logic we will write to develop our services is inside our services part, and the communication is kept simple. Okay, so the communication is kept simple. So this in this point all the communication between the individual, suppose a service A, the catalog service wants to communicate with service B, and the service B wants to communicate with the service C. So how will they communicate? They will communicate through the endpoints. Okay, through the endpoints. And what is the endpoints? Here the endpoint is nothing but our REST API. Okay, so the concept of REST API we will understand in our next video. Okay, but here you should remember that the communication through one service to another service is done by the smart endpoints, not through the pipes. Okay, not through the connection. Okay, in each service we have to write some. In each service we have to write some http method localhost 8080 slash catalog. Okay, so each service we have to write our REST APIs to communicate with each other. Okay, we will communicate. Suppose if a catalog service want to communicate with service shopping cart, then it will communicate through the HTTP method, not through the pipes. Okay, so similarly we will write a HTTP method here in this service also and in this service also. Okay, this is our discount HTTP method, and this is our ordering. Okay, so this is the point 3, that smart endpoints and dump pipes. If the catalog service want to communicate with shopping cart, then it will communicate through the HTTP method. There are various HTTP methods, like there are HTTP methods. There are HTTP methods. There are only 4 types of HTTP method. One is post, second is put, third is delete, and fourth is get. Okay, these are the HTTP methods which helps to communicate the service from each other. Okay, so we will move to the next point, that is our fourth point. And what is the fourth point? So the fourth point is design for failure. Design for design for failure. So design for failure is nothing but if we explain then the design of failure is failures are naturals in distributed system. Suppose a service might crash. Suppose you create a service. Okay, a service might crash, a network may go down. Okay, or database might become unavailable. The principle of design failure says that the system should always assume something will go wrong and be prepared for it. Okay, we actually what happens that you are creating service different services for different purpose. You are creating catalog service, you are creating shopping cart independently. Okay, you are creating discount logic. Suppose so there is a chance of failure. Okay, there is a possibility of service crash, that your catalog service got crashed due to the traffic, or your network may go down, or the database might be not working. So there is a chances of failure. Okay, so the principle of design failure says that system would always assume something will go wrong and be prepared for it. Okay, instead of building a perfect system that never fails, developers build a system that can recover quickly from failure. Okay, for example, if we took example, then if the payment service is down, okay, if the payment service is down, the order service should not crash, but instead inform the user to try again. Okay, suppose your service payment is failed. Okay, but instead instead of crashing the system, you will inform the user to try again later. Services can use retries, backups, and failure over mechanisms to handle failures. Okay, another approach is using circuit breaks. Circuit breaks is an approach to Circuit breaks is an approach to stop calling a failing service until it recovers. Designing of failure improves the reliability of whole system. Even if one system service fails, the rest of the system continues working. Okay, so this is the whole concept of design of failure. So if you want to define, if we have to define that what is design for failure, then we will say that microservices microservices must be designed to tolerate failure. Okay, many services might be unavailable unavailable at any time. Okay, so you have to be prepared that what happen if a system or if a service get failed. So instead of crashing the system, you have to maintain it by using tools like circuit breaks and circuit break spring boot. There is one more tool. This is spring boot actuator. These are the mechanism by which you can stop a system from failure. Distributed logging. Okay, these are the concept from which you can stop a system from failure. So this is the point 4. So the next point is decentralized decentralized data management. Okay, so what is this? What this point says? Each microservices has its own database or data store, allowing teams to choose the most suitable solution for their service requirement. Okay, the decentralized approach minimize dependencies and support autonomy or support autonomy, enabling teams to innovate and iterate independently. It makes the service more autonomous and less dependent on another external mechanism. Okay, so what are the key points of this? So the first is one is what are the key points if we want to define if we want to define that what is a what does what does decentralized data management means, then you can explain them that every services should have their own database. Okay, and only that service is allowed to communicate or connect to that database. Third point is other other service other service is not allowed other service is not allowed to connect to DB of other microservices. Or fourth point is if another service wants to connect with DB of another service, then they have to they have to make an they have to make a call to that service. Okay, so this is the basic concept of decentralized data management, that every service should have their own database. So that I explained here and here also, that every services have their own database. So this service connects to only this database. So this cannot be happen if this service wants to connect with this service. So this is not this is not possible. Okay, this is not possible if service A wants to connect with the database of service B, then they have to make an API call. Okay, so the service A have to make an API call to the service B database. So this is the only way to communicate with another database. Okay, so other service is not allowed to connect to DB for their microservices, and if another service wants to connect to DB of another service, then they have to make a call to that services. Okay, so this is the point 5 of the microservices architecture. So our next point is point number 6. So our next point is infrastructure infrastructure automation. So infrastructure automation means, so what does this concept says? Okay, so in service, basically in service based architecture, there are many services running at the same time. Okay, in service based architecture, there are many services running at the same time, manually deploying, monitoring, and scaling. Each one is very difficult. Okay, that is why the principle of infrastructure automation is used. It means that the tasks like setting up services, deploying applications, scaling them up or down, and monitoring their health should be automated. Tools like Docker, Kubernetes, Jenkins are commonly used for this purpose. If we took an example, we can say that if a service is receiving heavy traffic, okay, if a service is receiving heavy traffic, Kubernetes can automatically add more container to handle the load. Similarly, if traffic is low, it can reduce them to save resources. Automation also helps in quick recovery because if a service crashes, the system can restart it automatically without human help. Okay, so basically, what is infrastructure automation? Infrastructure automation means if your system is if there is more traffic in your system, then with the help of automation, they can create a copy of your services that can reduce the traffic of in your system. Okay, if you want to define that what is infrastructure automation, then we can say that microservices that microservices microservices rely on automation. Okay, automation for deployment, monitoring, monitoring and recovery, recovery, enabling, enabling rapid and reliable delivery of software. Delivery of software at scale. Okay, so this is nothing but it is very in simple word. If you want to know what is infrastructure automation means, if your infrastructure automation means it is very difficult to deploy. Suppose your project contains 100 microservices, so it is very difficult to maintain it. Okay, it is very difficult to deploy each server. It is very difficult to deploy each server, monitoring each server, and scaling each server is very difficult. So infrastructure automation use the system like Docker, Kubernetes, Jenkins. Okay, so this tools helps the services, microservices, to automatically deploy, monitoring, and discover and deliver the software at a scale. Okay, So this is the sixth point. So our seventh point is decentralized decentralized governance. So what does decentralized governance means? Wait a second. Let me take water. Okay. So what is decentralized governance means? Suppose you want to make a project. Okay. So decentralized governments authority and control are distributed across on autonomous team. So it allows. So decentralized governments basically means it allows developers to work with any technologies. Suppose a developer wants to build a project using Java. So decentralized governance allows them to, okay, you code in Java. If another developer wants to create to build a service using the Python language, then governance says that okay, you can create your microservices using Java language. So it tells that use the best technologies suited for the service needed. Okay, there is no compulsory that you can use only this language. So you can use any one of the language to build your microservices. Teams can use the best tool for the task and make teams satisfied, and as a result the other services and the end users too. Okay, so what decentralized government means? It is nothing but decision making and controls are distributed distributed across the teams and give them a power to make decisions independently make decision independently within the within the boundaries of boundaries of their respective services. Okay, so this is what means the decentralized government. Take card, it gives you the decision and the control and the power to use any of the technologies, what technology you want to use in your service. So this is the decentralized governance. So the next point is the next point is products, not projects. Okay. So what does products not projects means? Okay. So basically, actually, actually in old style, ठीक है? Okay, in old style IT, software was treated as a project. A project starts gets developed, and ends after delivery. But in service-based architecture, services are treated as a product. A product is a long-term asset that is continuously maintained, improved, and supported. Suppose suppose we took example of payment service. Okay, it payment service is not just developed once and left. It keeps evolving with a new features like UPI wallet integration, or international payment. Treating services as a product ensure that they remain useful and up to date with changing business needs. Okay. Teams are dedicated to owning and managing their service like a product company manages its product. This mindset shift improves quality because the same team that builds the service is also responsible for its maintenance. Okay. So products, not project, means microservices are treated as a long-term product with ongoing ownership and responsibility. This approach encourages teams to prioritize quality, reliability, and maintainability, fostering a culture of continuous improvement and customer satisfaction. So you don't have to make your so in this point, the basically means that you this point basically says that you don't treat your project as a project. You have to treat your project as a product. Okay, the project starts, get developed, and ends after delivery. But product is treated as a the product is a long term asset that is continuously maintained. So treat your project as a product. Okay, they suppose you created a project. Okay, so the project will be maintained after the delivery of the project. Okay, so you have to maintain your project after the delivery also. You cannot treat it like you created it, and after delivery your work is done. No, it is not good. So if you want to make your project as a product, then you have to maintain it after some time of or after. It is a long term asset, not a short term asset. You have to maintain it after the delivery also. Okay, so if you want to define, then you will say that microservices is microservices are treated as a is long term product with ongoing ownership and responsibility. Okay, so this is our 8th point. So our last final point is evolutionary design. So this is the last point of the microservices architecture that is given by the Martin Flower. So this basically this point says that microservices prioritized evolutionary design and incremental improvement over upfront planning in monolithic architecture. Services involve iteratively based on feedback, changing requirements, and merging business needs, enabling organization to adapt quickly to market dynamics. So basically, In big applications, it is not possible to design everything perfectly from the beginning. Okay, it is not possible. It is not possible to make everything everything perfectly from the beginning. Okay, it is not possible. So business businesses needs keep changing, and technology keeps involving. So that is why the principle of evolutionary design is followed. It means the system should be designed in a way that it can grow, improve, and adapt over time. For example, an online store. An online store might start with a simple payment service for credit card. Later, as customer demand more option, it can involve into multiple services handling like UPI, wallets, and international payment. So evolutionary design make the system flexible and ready for change. Okay, instead of spending years building a perfect design, developers realize small services and improve them step by step. This approach reduces the risk, speeds up delivery, and allows faster response to customer needs. In short, if you want to say that what is evolutionary design, so you can say that, or evolutionary design evolutionary design ensures that the system is never fixed but always improving. Okay, so this is the main line concept of microservices. I hope you understand. So we will summarize it once more. So microservices architecture. What is microservice architecture? Microservices solves the issue of monolithic architecture by breaking the application into small independent services. Okay, instead of making a single project, you will make a microservice architecture in which the project is divided into small part and independent. They will run independently without disturbing each other. So every service contain their own database. So later in 2013, uh, Martin Flower introduced the basic concept that if you want to create a microservices, then you should have to you should have if you want to if you want to create a microservice architecture, a microservices project, then you should include this thing in your project. That the first point in componentization, where services in which the all the component are breaked into the small parts called services. Second one is organized around business capabilities. In this each microservices is built to handle a specific businesses. Okay, third one is smart endpoints. Every services will communicate to other services with the help of the REST APIs. In next section, we will cover static method. Okay, post, delete, put, and get. So in fourth, design for failure. Microservices must be designed to tolerate failure. Okay, so any services might be unavailable at any time. So you have to use these terms or tools like circuit break, spring boot, actuators, and distributed logging. This helps the system from failure. Okay, the fifth point is decentralized database management. Okay, decentralized database management. Every service should have their own database. Okay, only that service is allowed to connect to that database. Other service is not allowed to connect to DB4. Another microservices. Okay, the sixth point is infrastructure automation. Microservices rely on automation for deployment monitoring. It is very difficult to monitor or deploy such microservices. So we use infrastructure automation. The seventh point is decentralized governance. Decision making and control are distributed across the teams. So you have the power, or you can make the decision that in which language or in which, with the help of which technology we want to create your project or create your services. So there is no any pressure from the manager or from the head of your department that use this technology for this service. So it is, so this is all upon you, that how you want to make your service. The eighth one is product, not projects. You have to see your project as a product for long term products, not for short term product. It's your responsibility to change it after time to time. And the ninth and final point is evolutionary design. It is not possible to make everything perfect from the beginning. Business needs keep changing and technologies keeps evolving. So this is the main problem, that technologies keeps evolving. Suppose today is the era of Spring Boot or microservices, but in future there can be there is a chance that AI/ML is taking AI/ML is taking our job or whatever. So in summary, if you want to conclude the class, that what we have discussed over an hour. So this so the summary is this, that all this principle works together as a microservices. Okay, componentization breaks the system into services. Business capabilities keep it aligned with the real need. Smart endpoints handle logic, and dumb pipes keeps communication simple. Design for failure builds silence. Decentralized data gives independence, and infrastructure automation makes running service easier. Decentralized governance provides freedom. Products, not projects, give long-term value, and evolutionary design allows growth. Together, this principle ensure that the software is scalable, flexible, reliable, and business friendly. Okay, so these are the basic concept of microservices. So I hope you all understand that how a microservice work. So let's meet in our next class, in which we will learn about HTTP methods. Okay, so thank you for thank you. So I am stopping my recording. So guys, next meet you all in next class. Bye.